So that last one, it looked pretty close to being inverses, but not quite. So instead of having to be given two functions and determine whether or not they are inverses, what if we could just determine what the inverse was? So there's pretty much three-step process to do this. First, we would like to write this in terms of x's and y's, not f of x's. All right, now we want to swap out all of the x's with y's and y's with x's. So step one is swap them out. X equals 2y plus 3. Next, we want to solve for y. X minus 3 equals 2y. X minus 3 divided by 2 is equal to y. And then we have it. Step 3 is simply write f inverse of x in place of y. So when we have found a function that is the inverse function, we use this special notation f inverse of x to say that this is the inverse function for f. Notice this looks pretty similar to the g that we had in the previous problem, but not quite. There was a little bit of difference. Here we have 1/2 x minus 3/2, where before we had 1/2 x minus 3. But this is the inverse, and this works for more complicated functions, as we will see in the next example. If we have f of x equals 2x plus 1 over x minus 1, we would like to find the inverse function. So we'll swap out x's and y's. So x is equal to 2y plus 1 over y minus 1. Step 2, we need to solve for y. So since we have fractions, we don't really like fractions. Let's clear out fractions by multiplying both sides by the common denominator, y minus 1. So I have x times y minus 1 is equal to 2y plus 1. Goal is to get all the y's on one side, so let's multiply out that left-hand side. Now, let's bring all of the y's to one side and everything else to the other side. I will subtract 1 from both sides. I will subtract xy from both sides. So minus 1 minus x is equal to 2y minus xy. Now, notice everything on the right side has a common factor of y, which I'll be able to factor out. 2 minus x times y. Left-hand side stays the same, how it was. Now, if I have something times y, to undo that, we just need to multiply both sides by 2 minus x. Those cancel out, and we're left with negative 1 minus x over 2 minus x, and that is our f inverse of x. So how could we check to see whether or not this is correct? Well, what should happen is if we do f of f inverse of x, we should end up with just x. In this problem, it would be kind of a pain to check since f inverse is this thing and f of x is also a rational function. It'd be, I mean, we could do it, but I don't want to. But there you have it. Also, if you want, you can check to see that f inverse of f of x is equal to x as well. So that was my step 3. That was my step 2. I should mention it, there's also a step 0. Step 0 was check to make sure that the function you started out with was 1 to 1. Because if it's not 1 to 1, you'll run into a problem. So our last example is if we try this with a function that's not 1 to 1. We already saw that y equals x squared was not 1 to 1. It does not pass a horizontal line test. It's parabola. But let's see what happens if we kind of skip that and just move on to here. So step 1, swap the x's and y's. Step 2, take the square root. Don't forget when you take the square root, you have plus or minus square root. And then write f inverse. So if this is f, then our f inverse is this. Now, what's wrong with this function? This function looks like plus or minus the square root of x. Plus the square root of x looks like this. Minus the square root of x looks like that. And this is not a function because this does not pass the vertical line test. So, not passing the horizontal line test up here means when we swap the role of x and y, we will not be able to pass the vertical line test down here. So what we can do, if we want, we could say, hey, let's make sure x is greater than or equal to 0 over here on the original function. That means we should only have the right-hand half. So when we do this, we should only have the positive or the top half. So if you want to find the inverse, we would have to restrict the x squared function to just greater than 0 or just less than 0. And then we would either get the top half if we use greater than 0 or the bottom half if we use less than 0.